Well, thanks for coming. Again, my name is Roy Williams. I'm a software engineer at Lyft, working on bikes and scooters, so I'd be happy to talk about that afterwards. But today we're talking about how we would adopt types inside of an existing production code base and the challenges that come with that. And we'll do a little bit of live coding to see how this works in action. So today we're talking about why we even add types to a dynamic language. We'll go over this very briefly. Way more talented people than me have already talked about this, so go look at their talks. We're talking about some of the challenges that come uniquely with production code bases, and then we're going to go through how to actually annotate a code base through an approach I like to call tightening the belt. So first, why even add type hints in the first place? Again, a bunch of talks by Guido and other people like that who can talk about this for hours, but in our experience, the biggest value has been with code discovery, it makes your code base a lot more approachable for newcomers and for modification. So if you have a piece of code that is never going to change, no one's ever going to look at it again, then yes, by all means, types may not help you at all. But if you have a code base that's rapidly changing and potentially changing faster because you have new people coming on board, then types are super useful to get those people familiar with your code base. We do find that it finds bugs as well, but personally, I think most of the value comes from the discoverability side of things. But it's not all sunshine and rainbows. When you're first starting to, I like to think there's a bit of an activation function when it comes to adopting types. When you're first adopting types, there's really not a ton of value, to be totally honest, because there's really nothing to type check against. There's typeshed, which has the standard library and some common third parties, but you're not going to find any bugs, and it's a bunch of work, and sometimes a lot of projects just die here. Moving up the activation function, you eventually get some traction, and it starts being really useful for discovering code, but some of the downsides kind of in this phase is this is where people's expectations for types don't match up to the reality. So you may find people complaining that, well, why didn't MyPy find this bug that could have been caught, or this typo that could have been caught? And usually it's because there's not enough type information. But on the flip side, people start adopting typing here. They start doing it themselves. You don't have to push them. You start getting advocates inside of your organization. And then, of course, we all want to be here, the plateau of happiness, where it's really easy to navigate your code base. You can find typos without waiting on tests. You can enforce standards with typing. You can say that all new functions have to be typed, or all functions have to be typed. And we really want to get here. And so the thrust of this talk is how do we get from that kind of very beginning phase where we're not really having a lot of value to maybe not all the way up the hill, but pretty much towards the top with tooling. And we'll be talking about an approach here I like to call ratcheting the belt. If you've ever seen a belt ratchet like this, we have a problem, we want to throw a belt over it, just kind of get our arms around it, and then slowly tighten the belt until we have a fully typed code base. Cool. So if you want to follow along, you can go to go.lyft.com/pygotham, and there's 14 branches there that walk you through what we're going to do here today. I've been doing demos for a while. I know the demo gods are unjust, so I'll just be switching branches to change code here. Let's go ahead and check this out. Cool, so let's go ahead and get started. So today we're going to be working on a code base called Mackup. Mackup, it has almost 8,000 stars on GitHub. It is a project that lets you back up like PyCharm settings or vimrc files or bashrc files. So if you move to a new laptop, all of your settings are there. Really popular, bunch of commits, some tests, but no types. So we have the code base open here. You can see that it's a 2 and 3 compatible code base with the kind of import tricks here. Not a lot of types though, and it's around 500 lines of actual code. So let's go ahead and get started. So first things first, I'm not going to pip install MyPy here. We'll just have it already installed. The first thing we're going to do, oh, yes. There we go. Thank you. So the very first thing we're going to do is just run MyPy for the first time. And we get a couple of errors. Even with this code base, MyPy is not happy. But before we go and fix that, let's integrate with CI so we can make sure we catch these errors. So this project is using Circle CI, and we will change to step 1, adding MyPy to CI. So we add 2 new rules here. The big thing to point out here is that even though MyPy can type check both Python 2 and Python 3, MyPy itself is Python 3 only. So you'll see we're running inside the Python 3.7 image for both Python 2 and Python 3. But let's get back to fixing those errors. So the error is coming from here. We're doing this trick where we want to import something in Python 2, but something different in Python 3. So we try to import the Python 3 version. If it fails, we fall back to Python 2. MyPy doesn't actually understand this. Instead, MyPy actually understands sys.versioninfo. So we're saying if sys.versioninfo is greater than 3, import this module. Otherwise, import that module. MyPy will completely ignore this branch in Python 3. And we're clean. We can go to our branches. And I've already pushed all of these, so you don't have to wait for CI. And we see we have a green check mark. Everything's great. But what does that really mean? Like, how much type coverage do we have? And to facilitate that, MyPy actually supports outputting Cobertera XML. Now, Cobertera is a common code coverage format. So to facilitate that, going back to our Circle CI config, we're going to add this command here for we want the Cobertera XML report. We're going to put it in the local directory. We're going to move it somewhere where CodeCov is going to look for it, and then we're going to upload it to CodeCov. So what does this look like? How much type coverage do we really have with just adding in MyPy? And it turns out not very much. We have around 6.5% of our code base typed. We see the constants are 100% typed, but this is kind of what you would expect. Out of the gate, MyPy is only going to check top-level functions. So this is a good start. We have a belt around the problem. We can't check in any invalid type top-level definitions, so we're on our way. So in terms of our activation function, we're somewhere around here. We're at the very beginning. But let's see if we can do better. So as I mentioned, this project has tests, which is great. It also has some tests. And we can actually use those to infer type information. Dropbox open source a tool called pyannotate. Now what pyannotate will do is it will watch your program run, and it will extract type information. And then it can reapply that type information back to your code base. So in this case, I ran the tests. You can look at the pyannotate documentation, but I've just added in that I want the output to go here into annotations.json. And if we open that up, we see a JSON file that has a bunch of functions and the type signatures we saw of those functions. So util test always took in a stir and always returned a stir, and there were 5 samples of it. And just to show this output a little bit cleaner, so you can use pyannotate to reapply those types, and it will apply Python 2 types, which is great. Now we've got some types in. We can go to utils and actually use those types. So can files be synced to current platform? We know path is a string. So I get autocomplete here. Awesome. Well, let's see if MyPy passes. Oh, it's not going to pass. So it's complaining that in utils 251, we returning an optional string, or we expected a string, but we return an optional string. So MyPy is null aware. MyPy will MyPy is null aware. MyPy will error out if you return null and you're not supposed to return null. In this case, it makes sense, right? Google Drive home is none. We have this function error if Google Drive is not none, and then we return Google Drive. And so yeah, it still can be none. But if we look at this function here, it just exits the program. So can we express this to the type system? And it turns out we can. So we're going to use a MyPy extension here called noReturn. Now, noReturn signals to MyPy that this function will never return. You don't evaluate any other branches after this code base. So what this signals to MyPy is that if we call error, then we can't be in the other code path. So error, if Google Drive home is none, we wind up here, we exit the program, so we know it's not none here. And we pass. Great. So let's see what that did for us in terms of coverage. So we fixed the build, and we're at 39% typed. That's not bad. Like, we didn't really do anything here. And furthermore, we see that utils is almost totally typed. So can we tighten that ratchet a little bit more? Can we make sure that utils remains typed as we continue iterating on this code base? And it turns out, of course, we can. So we're going to lock down the code base. So what we're going to do is we're going to create a mypy.ini file. And inside of that ini file, we're going to say markup.utils disallows untyped defs. So if I go back to that function with that mypy.ini, and I create a new function, foo, with no type signature, I get an error. So now that function will remain typed. None of my coworkers can do my hard work. It's great. But 40% typed, that's not enough, right? That's maybe we're up here on our activation function. We're just getting started. So can we do any better? So in that first example, we only applied simple types. Pyannotate has this concept of simple types and complex types. Simple types are basically primitives to primitives. So if a function always takes in a string and always returns an integer, it's considered to have simple types. But if it takes in a set of strings, not so much. So let's see what it looks like to apply complex types. So we're going to call pyannotate again, but we're not going to pass in -s flag, and we're going to annotate a bunch more functions, including setting things to set of strings. So what does this actually look like? So now we have some more complex types like set, optionals, things like that. Config parser. And we still have some errors. Oh, man. What's going on here? No. So it's complaining here that apps to sync is a set, but it doesn't know the type. It doesn't have any local type information. So we can easily fix that. We can look. We can see the function expects to return a set of strings, so that's probably a set of strings. And so we'll use the Python 2 syntax for inlining types here. So we add in the set of strings, and mypy is happy. Great. Let's look at our type coverage again. And now we're at 47% typed. Again, we haven't really done anything here. But that's not enough. I mean, but that also means their test coverage isn't very good. So how can we go even further? So Pyannotate supports instrumenting your running code, even if your test coverage isn't where it should be. So what does that look like? So we'll take our main function here, and before we actually our main class, and before we actually invoke the main method, we will in Pyannotate create a context manager to collect type information, and then dump that out to that same annotations file when we're done. So let's go ahead and delete that annotation file. And let's just invoke markup. OK. And now it's dumped new annotations for code that actually ran when I executed the program. And I can use that to apply more type information. The main thing to note here is that you have to, it won't merge the annotation files. It will just overwrite them. So if you're following along, you have to apply after invoking every command. So let's see what this looks like once everything's said and done. And we have a lot more type information, including the markup option, tuples, things like that. Let's run mypy again. And we see we still are missing some annotations. So let's go ahead and take a look at what it's complaining about. So one of the things that it's complaining about is that I can't assign to a method. Now there's already a bug in MyPy about this. I won't bore you with it. So just don't look here. It's fine. Don't worry about it. We also have this dictionary of apps. And we see it has a name field and a configuration files field. And maybe we want that to be a little bit safer. So how could we fix that? So for this assignment here, I'm just going to say type ignore. So in any line, you can type ignore, and MyPy says, sure, that's probably OK. But for the apps file, I want a little bit more safety. Like, it seems pretty core to our product here. So I'm going to use something called a type dictionary. So MyPy has this concept called a type dictionary. Type dictionaries are ways to have schemas inside of the type system for dictionaries. So you have an app entry. It has a name that's of type string. It has configuration files. That is a set of strings. And it's actually enforced by the type system. So we run MyPy. Everything passes. Great. Well, let's poke around and see if that actually works. So say instead of assigning the name to app_pretty_name, I assign it to 42. What's going to happen? I get an error. It expected a string, and I got an integer. All right. What if I misspell name? I get another error. App entry has no key NME. So if you have stringly typed code, this can be a really powerful way to make sure your code stays safe. And let's go back to our coverage information. Let's see where we're at. We're at 94% typed. And again, I've done nothing, which is great. This is a great place to get started. And it feels like we're real close. There's some functions missing in main, and I really want to get those too. So the easiest way to do this, once you're close to find the untyped functions, is just to mark everything as disallowing untyped defs. And we're going to get 2 errors for 2 functions that are missing type annotations. Get pretty app names. Yep, no type annotation. And get name. But they look pretty simple, string to string, and returns a set of strings. OK. So let's go ahead and fix that. We have the type annotations here. We're good to go. Let's see where we get. Drum roll, and we're 98% typed. Every function is typed. And even with that, even with forcing us to have no untyped defs, we have no errors. No one else could add untyped defs here anymore. We now have a fully typed code base in the course of 18 minutes, which is pretty good. But say I want to go further. I don't really like these string comments. I don't know, maybe Python 2 burns an entire fire. We're Python 3 only. So how can we get rid of this? So there's another useful tool called retype, which is used for applying Python types to a code base. So if I call retype on this function, on this file, and all this will be in the slides, it will take those Python 2 style comments and make them Python 3 style comments. But we still have one more problem here, which are these little no QAs here. So I had to add no QA to all these imports to make Flake8 happy with the Python 2 comments. Flake8 won't look inside of type comments, and so you just kind of have to say ignore these. So how do we fix that? There is a tool called YesQA, written by another engineer at Lyft, that will remove any no QA comments, rerun Flake8, and if it passes, leave it removed. And now we're good to go. We have a fully typed Python 3 code base in 19 minutes. No more of these typed comments. It's pretty great. Now going back to our activation function here. So we've applied our complex types. But now we've burnt the bridges to Python 2. And we're just our happiness is on the moon. We're where we want to be. So great. So hopefully I've given you a good flavor for how you can move from having a code base that has absolutely no types to a code base that's relatively well covered by types pretty quickly through tooling like pyannotate. There were only 2 methods that I had to actually annotate by hand. Cool. So with that, we have about 5 minutes for questions. Yeah. Thank you. Yes. So the question was, if you're still on Python 2, can MyPy help you move to Python 3? So one example here, import text. So the biggest pain is with bytes versus strings, of course. So MyPy has an affordance called text. Let me go back to the fully typed branch. So text is a way of saying in Python 2, this is Unicode, in Python 3, it's a string. So this function here actually returns Unicode. If I were to make this string, I get a type error in Python 2 saying that I'm returning Unicode, but it expects a string. So this can help you with kind of bytes versus strings issues. Yeah, good question, though. Cool. Any other questions? It was like, yeah.
Any strategies when dealing with huge libraries where it's not feasible to annotate the entire library?
Mm-hmm. Yeah, totally. I think the big thing for a lot of these big projects is go from the outside in. Like take the API that people are consuming and annotate that, and then work your way in. Because that's where you'll have the most value from that discovery and safety standpoint. And then working your way in has value for the project itself. There's also a separate PEP that I'm blanking on the name of now, where libraries can publish type annotations. Like NumPy has a separate package for the type stubs inside of MyPy. That can also be a useful way to go about it, is to just publish the stubs first. Yeah, good question, though. Yeah?
What are some of the quirks of pyannotate discovered?
What are some of the quirks of pyannotate that I've discovered? Let's see. I've fixed a lot of the ones that were kind of especially quirky. For example, if a function, if it only observed a function taking in none for a keyword argument, it would say that the type was none. And so the fix that I made that optional any. But for the most part, like where we start really running into things is we have hugely megamorphic functions that are like union of foo, bar, raz instead of bar. But that's also usually like a smell that code is probably really tricky to work with if there's 5 different types that can be passed into it. So yeah, so where it is quirky, it's kind of a code smell anyway. Yeah, good question though. Yeah.
So pyannotate works in generating both annotations for Python 2 and Python 3?
Mm-hmm. Python 3 will parse the Python 2 type annotations. And then if you want to go to Python 3, you can just use retype to convert it over. Or you could use monkey type from Instagram, which will only do Python 3 annotations. Yeah?
This is sort of tangentially related, but have you, at work or in personal code, ever used typing at runtime to do cool things?
The question was, have you ever used typing at runtime to do cool things? The answer is no, and I kind of don't think you should. One of the things that came in Python 3.7 is a future import that makes the types have no side effects, which is good for type safety. Like in Python 3.7, if you use that future import, you don't ever need to import things that aren't, you don't need to import things like list or set. So it has no impact on runtime. So I would like to see it more go that way. There are projects like Cython is starting to use type annotations, so you can mark things as an integer there without like their magical Cython int. Yeah, so time for one more question. Leo.
MyPy or Pyre?
The question was MyPy or Pyre. So we use MyPy at Lyft. We experimented with Pyre, but we found that it was still missing some features that MyPy had that weren't part of PEP 484 yet, like type dictionary or no return. I actually don't even believe it supports strict optional, although that may have changed. The Pyre team's great though. Like Peter and those folks are doing amazing work. So yeah, hopefully you will catch up with them soon. But yeah, I'm glad that there's that kind of ecosystem here where there's MyPy and Pyre and a few different, and PyTyped from Google, and a few different type checkers here competing. Which I think has been hugely successful for the project. Cool. So with that, thank you, everybody, and I'll be around for any more questions.